So as we continue our learning process of critically appraising different types of research articles, the next on our list to look at is systematic reviews. So let's talk about systematic reviews. First and foremost, let's talk about the purpose of a systematic review. The purpose of a systematic review is to make sense of multiple articles focusing on the same question. It's an overview used to make an overall picture of results. Now, I know on my slide it says several studies, but it doesn't just have to be 3 specific studies. The point I'm trying to make is that you can look at an array, a range of studies, and that are focusing on one question, pull them together, and complete a systematic review to make an overall picture. You want to make an unbiased assessment of as many of the studies as possible. This is the purpose of a systematic review. And because it can lead to the most reliable synthesis of the data. The aim of a systematic review is to, one, answer a particular question. So we've talked numerous times and we've completed our own PICO questions. We're looking at a particular question. 2, we are identifying all relevant evidence, whether it be published or unpublished. Then we are appraising the information, which we should be used to at this point, by looking and assessing quality and validity of each study that is added into the systematic review. Because remember, it's a pooled group of information, so you're assessing the quality of each study that you've incorporated or stated you will be using to complete this review. Then you synthesize the information by determining the findings from each study in an unbiased way. So once you synthesize each study individually, you're going to interpret by discussing the findings of all the studies and present your conclusions of it overall. Why is this important? Well, there's a few reasons why they're important. So first and foremost, and I'm starting from the 3rd bullet point, there's a large amount of research information available at this time, and as we all know, it can be time consuming to personally piece through every piece of research that we are looking at to make sense of a question. And why and how that's perfectly fine to do, but the purpose of a systematic review is to reduce that by pretty much having it done. So if you're the one reading the systematic review, somebody has done most of the work for you in a sense where they have taken as many studies that they thought were great or of good quality based on their search criteria, the inclusion exclusion criteria, and decided that this is the information that they would use to answer a question. And if you're the one completing the systematic review, well, then you're the one deciding on a good pool of quality evidence to make sense of a question. I also would like to just add that systematic reviews can examine both quantitative and qualitative evidence. It can do it separately or it can do it together. But just note that if it does use more than one type of evidence in its examination, then that is referred to as a mixed method systematic review. So again, the process of reviewing a pooled group of evidence is, first and foremost, you're going to formulate a research question. You're going to design a search strategy, which we again are very familiar with doing at this point. You're going to search databases using inclusion and exclusion criteria that you felt best represented what you were looking for to answer your question. You're going to review a numerous amount of papers. And then from that group of papers that you reviewed, you're going to identify the best quality of evidence to be used to answer your question. Once you have identified that information or that evidence, you're going to compile the data. Then you're going to complete an appraisal. You're going to synthesize and formulate a conclusion. When you're critically appraising systematic reviews, there's a few things that you're going to look at. First of all, you're going to look at the literature search. Did it include published and unpublished materials? What was the quality control? What type of study was used? Were they looking at randomized controlled trials or cohort studies? What were the scoring systems used to rate studies? And what was the analysis performed? And how many experts performed it? You're also going to look at homogeneity of the studies. And you're going to look at their presentation of results. Is it clear? Does it make sense? And most importantly, is it correct? Then you're going to determine if you could apply this to the population that you are generally probably seeking this information for. Now, when you're looking at quality of the studies that are included, you're looking at the tools used to assess validity and quality. You're looking at what the tools consisted of, what were the tools, essentially, and look at how many raters use the tool. Do the articles or papers state how many people use this tool? And was there quality cutoff? So now if you're the one reviewing a systematic research, or I'm sorry, a systematic review, somewhere within that information or that evidence of those articles that you're reading, it should state if there was a quality cutoff. And if you are the one completing the systematic review, then you should state if there is a quality cutoff. And then last but not least, you're going to look at effect size. Now, what is homogeneity? Well, I'm essentially just really generalizing this to make sense in terms of what we're going to do and what it is. But there are more concrete definitions, but this is just to give you a basic concept of what it is. So homogeneity consists of is looking at consistency in the results of included trials. And these are the included trials that you're using for the systematic reviews, or if you're reviewing a systematic review, looking at consistency among the results within the trials that were included. Okay, so you're looking for similarities in the direction of the results. For heterogeneity, you're looking to see if there is no or very little consistency of the results. Is there a difference in the directions of where they're going? And then it's important to note that there is both clinical homogeneity and statistical homogeneity. Now, when you're assessing for homogeneity, you're looking at whether the outcomes are similar or different between your studies. You want to understand why there is, if there is heterogeneity, and determine the range of effect size. This is where the statistical heterogeneity comes in, because if there is a difference, you need to make sense of why there is a difference. Usually when you see heterogeneity within the articles or papers that you're reading, well, then you need to pull that information and make sense, and you would do this by using a meta-analysis. Now, we haven't talked a whole lot about a meta-analysis, but we will. So to give you a basic idea, when you're using a meta-analysis, or a meta-analysis in general, is essentially data from individual study pulled together quantitatively and reanalyzed using statistical methods. So following a systematic review, data from individual studies will be pulled together and they will be analyzed. Okay? The rationale for doing this is that by combining the samples of individual studies, the overall sample size is increased, thereby improving the statistical power of the analysis as well as the precision of the estimates of treatment effects. This is done in two stages, or I should say a two-stage process. First, it involves the calculation of a measure of treatment effect with generally a 95% confidence interval for each study. And the summary statistics that are usually used to measure treatment effect includes our very familiar terms of odd ratios, relative risk, and risk difference. The second stage of a meta-analysis is the overall treatment effect, which is calculated as a weighted average of the individual summary statistics. And it's important to note that data from individual studies are not simply combined as if they were from a single study. Greater weights are given to the results from the studies that provide more information because they are likely to be closer to the true effect that is trying to be estimated. And this is generally seen using forest plots. Now, I have an example of a forest plot here, so I kind of want to break down what you're looking at. Now, this is an example that I took from a study, which you can see later in the references or citations. But this is from a study that had been completed that was looking at efficacy of probiotics compared with placebo in the prevention and treatment of diarrhea associated with the use of antibiotics. So the relevance of the study for this purpose is, well, there is none. I simply want to give you an idea of what a forest plot looks like and to kind of explain what you're looking at. So essentially, when you have a forest plot, you're looking at the results of a number of studies that have been pulled together. And those names of those studies are usually on this side, what you see here. So these are the names of the studies that were pulled together. And these are the first authors of the primary studies included, so the main studies. These black squares that you see represent odds ratio of each individual study, and the horizontal lines, sorry, I keep losing my mouse. The horizontal lines represent the 95% confidence intervals. The areas of the black squares represent the weight each trial contributes in the meta-analysis, okay? The solid vertical line essentially correlates or corresponds to no effective treatment for this study, and you are looking at the difference between them. So, like the overall treatment effect, which is also calculated. This diamond here, this diamond represents the combined treatment effect. And as you can see, you have your numbers over here as well. And the horizontal tips represent the 95% confidence interval. So this is just kind of an overview or just a look at what you will see when you see a forest plot. We will go into more detail about it, but for the purpose of understanding what you're looking at for heterogeneity within your papers or your articles, I just want to give you an example of what a forest plot is and what you're looking at and what does it mean. Okay, so basically this is looking at the differences found between the two groups and determining was it statistically significant by looking at odds ratios and the weights and the confidence intervals. Now these are some things that you're going to see a lot when you're looking at heterogeneity information and looking at forest plots. This is how they pull together the information to make sense of it. So, when you're looking at or you're evaluating the validity of a study, you're looking at the methods again, okay? You want to look at the quality of the methods. Is the question in line with the population, intervention, treatment, and outcome measures? Were they clearly defined? What is the population? What is the intervention or treatment? And what are the outcome measures? You should be able to pinpoint that out, and you should be able to write what they are. In the inclusion and exclusion criteria, are they aligned with the type of research design being used? What are they looking at? What are the inclusion and exclusion criteria? Are we using randomized controlled trials or not? You need to be able to assess that and understand that by looking at the inclusion and exclusion criteria. Or again, if you're the one writing the systematic review, you need to clearly state this. And is the research method clearly outlined? Can I understand it? Can I follow it? What is the search method for this systematic review? Or again, if you're the one completing the systematic review, then you need to clearly define what is the search method used. When you're interpreting results, you're looking at a few things. One, sorry, there's an error in here. You're looking at were the results consistent throughout the studies being reviewed. Two, you're looking at what were the overall results. And three, how accurate or precise were the results. So this is pretty much all that I have for now for systematic reviews. I wanted to provide you with one popular site that you will be using a lot for this part or this module to complete systematic reviews and search for systematic reviews. Make note of this because it's going to become one of your best friends. So to just kind of conclude everything that we were talking about, systematic reviews apply scientific strategies to provide explicit fashion on a summary of all studies addressing a specific question. So it allows taking a lot of information and pulling it together to make sense of it in a bigger picture. Meta-analysis can often accompany a systematic review and can increase power and precision of estimates of treatment effects. And generally, you will use this. It provides a great background when you need to when you need to understand many articles for one question at a time, okay? It does that for you. And it's important to understand what you're looking at and what you're reading. You should be able to interpret and write your own systematic reviews if needed. This is it for the systematic review or module 6. If you have any questions, don't hesitate to ask me.